Toshiko. I want to thank Toshiko. She's not here. Hopefully you're online for calling us all to be mothers. And I'm super honored to share the stage with these incredible women. Dori, thank you so much for setting the cultural context. And for Susannah, where are you? For giving the physical context. And I'm hoping to provide you with the biological context, if you may, and take you 250 million years back, and then bring you back to the future. So it's a very exciting time for design, as we all know, because as designers today, designers of the physical environments, the environment, architects, engineers, product designers, we are today authoring tools and technologies that allow us not only to design the shape of products and objects and buildings, not only their form, but also their formation, right? So not only the products, but the processes by which to create these objects and place them in the world. And over the past 10 to 15 years, we've been working with biology and with synthetic biologists in the last few years to bring some of these tools into architectural design and into product design, and to help shift the discourse of design across scales, across applications, from the industrial era, from objects that are static, that are discrete, that are mass manufactured, to what we call the biodigital era, objects that are dynamic, that have complex hierarchy, complex structures, that are mass customized, where the product is the factory. So I direct a team that is very interdisciplinary nature at MIT called the Mediated Matter Group. And in order to tackle interdisciplinary research, we also need interdisciplinary tools and environments. And one of these environments that we've created by designers, for designers, is a biosafety 2-level wet lab within which we can synthetically engineered microorganisms that can augment our products and our physical environments. So inspired by Paola's call, and I'm so happy that this conference has come into being, I have done my best to unite the Democratic and the Republican parties of environmental design, the sustainable camp and the ecological camp, those who believe as part of the conservation movement that we should maintain the status quo as is, do not touch nature, do not design nature, do not dare to fix nature, with the ecological movement, the one that claims designing nature is part of the natural evolution of life on Earth. And so I took all of the prefixes I've heard and read over the past few days surrounding broken nature, and created this cycle which is not perfect yet, it has many intellectual holes, but I hope brings these camps together to the original Republican Democratic Party. So respect, reflect. Of course, I started with Dori, because in order to speak, one must listen. Respect nature. So respectful design, reflect, replenish, recover, restore, reclaim, refine, and renew. And then that cycle continues, and of course, in order to augment, one must first respect. So the projects are set in those 4 quadrants of the diagram. The first, respect and reflect, taking you a year ago to when we were commissioned to design a project for the London Design Museum. It was a collection of death masks that explored what it means to design and build living products. A death mask that transforms into a life mask, if you're a livable, wearable, or product. And in this project, the first series, we looked at respect. We looked at the indigenous communities, at the ancient relic of the death mask across various cultures. And then in studying those respectful designs through computational algorithms and various additive manufacturing techniques and technologies, this one specifically with Stratasys, we've moved to more perhaps utilitarian products. In this case, a mask for Björk that is designed as an exoskeleton that Björk wore while she was singing or giving her performance, that is designed almost like a second skin. So it's designed as a continuous system that moves from bone to ligaments to tendons to as a connective tissue that is a single tissue, unlike in the industrial age where all things are made out of parts. This mask, this wearable, this product, hopefully in the future a building, made of a single system that only varies its properties as a response to environmental constraints. So from digital materials to programmable biopolymers, we've looked at replenishing and recovering the environment. We've been working with natural materials, materials that are taken from the ocean and returned from the ocean, taken from the sea, but also the land, and returned to the sea and the land. And that's what we call a material ecology, a vision where everything that is material in our physical environment, the clothes we wear, the products we use, the buildings we inhabit, are designed as part of the natural ecology. And in a world where we're designing products that generate 300 million tons of plastic a year, in this case, you're looking at a 5-meter structure that is almost entirely biocompatible and biodegradable on demand, that is made as an amphibian structure, part sea, part land, partly shrimp shells, chitosan, and partly cellulose and pectin, made of apples and shrimp shells and trees and bone, calcium carbonate as well. And all of these come together in a parametric chemistry to enable us to design products and structures that could be eaten. A wearable gut that can be worn on the body, and by way of exposing the body to solar energy, one generates the energy one is required to feed one's body and the baby. So in this case, a first of its kind microfluidic wearable that contains micro to macrofluidic channels that are printed with soluble support that enable us to introduce or to contain synthetically engineered microorganisms that can photosynthesize and generate sugar cubes in the pockets for free, if you believe the sun comes for free. And on that point, in the larger scale, moving from wearables to architectural scales, the ability to author new technologies such as, for example, our optically transparent glass printer, which enables us to generate objects that the geometry of which is independently authored externally and internally, unlike glass blowing, which allows us to potentially harness and harvest solar energy on demand. Think of the scaling, the ability to scale that in large context. I like to work in that space. My team enjoys this space because it brings together the production of new technologies, the generation of new scientific knowledge, and of course the creation of useful products and objects. Contained living materials. I mean, we've been working a lot in the area of additive manufacturing and arrived now to a point where we can design at the scale of a red blood cell and even a sperm cell. And that, of course, has biological implications. And the second series of the death masks of Vespers 2 explores what happens when we move from respectful design to this renew design, the ability to contain those channels in a wearable inside a building that can harness biological life. All the pigments that you're looking at in this slide are entirely biologically generated. And so these microorganisms are synthetically engineered to create this variation of pigments across the surface and volume area of an object. And the mask is an excuse to explore in the small scale, and then, of course, later scale up to the building and the body. But the ability, again, to harness and include or incorporate molecular inducers as part of the additive manufacturing technology allows us to create what we call hybrid living materials, materials that are partly man-made, woman-made, human-made, human-woman-made, and partly biological. And finally, programmable materials, of course, which pose the inverse question of sort of phenotype, genotype design and generative design, not asking, assuming we have these materials and these constraints, what forms can we get, but rather asking, assuming we want to arrive at this kind of form, what kind of genetic code must we engineer in order to generate this particular wearable, this particular building facade, and to literally grow it. All of these studies are easily done at the microorganismic scale, and of course, when you scale up to organisms beyond bacteria, it gets even more interesting from an ethical perspective. So the Silk Pavilion, which many of you know, was a 3-meter diameter pavilion that was designed and built using is the wrong verb, inviting 6,500 silkworms to spin an architectural bucky dome with us. And what was interesting about this project is that it enabled the silkworm to entirely naturally metamorphosize without boiling a single cocoon, and thereby question the way we design with silk in silk farms in China and India and elsewhere in the world. Can we get rid of this process of boiling altogether and co-fabricate by cohabitating? This is not only true for silkworms, but also for bees. Can we create, in this case, synthetic apiaries that are designed as perpetual spring environments that can contain the bees during the winter months when they usually go dormant, many of which die? And what does it mean to arm a robotic arm with a set of pheromones and to have this robotic arm act as a queen bee? What happens when technological augmentation supports eusocial organism connection and communication in an age when bees go extinct, and 5 years later, of course, humans go extinct? I will end very quickly with the commission to Paola's show, Broken Nature. I've spoken briefly about Vespers and our ability to create melanin, our ability to create pigments using biological organisms. When we finished the Death Mask series, of course, people said, what is this good for? What is it useful for? All these questions that we always get. But of course, these are, as Susannah says, pilot projects, projects that provide the opportunity to create new technologies. If you switch, if you move from pigments to antibiotics, right? Pigments to melanin, pigments to useful chemical substances, all of a sudden you get a range of products in various scales that are useful. So we have found that we can today engineer melanin. Melanin is the pigment of life. It can be found across, believe it or not, all 6 kingdoms of life. So way before us humans arrived on this planet. It has so many incredible advantages: chemical, biochemical, structural, mechanical, and it can be synthesized in 3 methods. Biological, of course, using melanocytes; bacteriological, very stinky; and chemical. And so we've explored the ability to create a set or a range of these melanin pigments. And of course, we know that with and on the human body, melanin protects from radiation, from UV radiation, and is today considered 10 times more expensive than gold per gram. So in the age of global warming, those substances that define us as humans are the new jams, are the new currency. I'm going to skip the chemical synthesis and show how we scale up the ability to process melanin in a bacterial dish, in a Petri dish, to the architectural scale. And again, using those three methods. Biological, using hair, for example, any of your hair would do, and extracting melanin from your hair, my hair, into those channels. And again, programming matter and programming life in a single object. In this particular example, you're looking at melanin extracted from feathers, incorporated into a form that was computationally grown, additively manufactured, and biologically augmented. But, and I will end with this, perhaps one of the most enticing, moving features of melanin is the dichotomy, the roles that it has played in the dichotomy between the biological and the cultural. How is it that a substance that has been biologically so constructive become societally so destructive? And now we start over with Dori's presentation, right? And so as designers, now that we can bring this substance into the architectural environment, what does it mean to create an architecture that has a biological significance, a first of its kind biological building that biologically provides UV protection, but also incorporates the whispers, a true biological wailing wall, of its inhabitants that can change its color and the density of its skin based on the zenith of the sun, can darken when the sun is up, and when the sun sets, of course, open the building to the sky and to the stars. We have been very honored to work with Ravi Naidu, the founder of Interactive Africa and Design Ndaba, to look into designing a structure such as this for Signal Hill in Cape Town. And we have been studying Cape Town. It's a natural environment and biological environment in order to come up with a proposal for a biological wailing wall that brings all of these hues of melanin, all the shades of diversity into a single structure. And the first demonstration of this technology will be with Paola, March 1st in Milan, where we will be demonstrating either 1 or 12 or somewhere in between columns that demonstrate our ability to control the distribution of melanin, thereby augmenting structural, mechanical, biological, and hopefully also humane and emotional issues concerned with these technologies, the cultural and the biological implications of these technologies in an age where we are all called upon to mother nature. So thank you very much, and I think the panel begins now. Thank you.